Hello, welcome to Science Chomp. Today we're going to be looking at dot-cross diagrams for covalent bonds. So we're going to have a look at three different molecules, H2, CH4 and O2. Remember, covalent means they're all non-metals. Okay, so the first one is hydrogen. Hydrogen has got an atomic number of 1, meaning it has 1 electron. And to have a full shell for the first period, remember, you only need 2 electrons. So let's have a look. First of all, you draw your hydrogen and you give it an electron. Then you draw the second hydrogen. It's like a Venn diagram. You make sure the circles overlap. And you draw the other thing as a circle. Now, the reason it's a dot and a cross is because you need to know where the electron is coming from. Okay? Now, if you have a look at this hydrogen, it's giving 1 electron. But with that, because it shares the electron, you've got 1, 2. With this one, you've got this electron here. But with this, you end up with 2. So each one ends up with 2 electrons, but we haven't added any electrons into the mix. Okay? Now, if you wanted to draw this without doing the whole dot-cross diagram, you would do it like this. So you've got hydrogen, single bond, hydrogen. Single bond because 1 pair of electrons being shared. Okay, let's have a look at CH4. Now this is interesting because carbon has 4 electrons on the outside shell. And I'm only concerned with the outside shell. I'm not going to draw the whole thing. So let's have a look at what happens. You've got carbon here. And it's got 4 electrons. 1, 2, 3, 4. It's 4 electrons short of a full shell because a full shell is 8 electrons, okay? That means it forms 4 bonds, okay? 1 for each electron that it's short. So let's just have a look at what happens. And I'll draw the hydrogen in yellow this time. Got 1 there, 1 there, 1 there, and 1 here, okay? Now, when I draw the electrons for the hydrogen, they're going to be over here. Remember, they've got to overlap. It's going to be wrong. If I draw the electron here, it's wrong because that's outside of the carbon atom. And remember, the carbon wants to share it. Okay, so now, if you have a look at the carbon atom itself, on the outside you've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it fulfills having 8 electrons. You look at the hydrogen, 1, 2, 1, 2, 1, 2, 1, 2. So they've all got full shells now. That's stable, that's good. Okay? Let's look at another one. Let's look at oxygen. Now, oxygen's a good one. You'll like oxygen. Not a lot, but you'll like it. Let's get rid of all of that. Okay, so how many valence electrons does oxygen have? Well, it's in group 16, which means that's 6. So let's just draw those. You got 1, 2, 3, 4, 5, 6. I always tend to draw them in pairs. It makes it easier to draw. Easier for the examiner to check it as well. So nice hint there. Okay, and you've got another oxygen. And I'm going to draw those electrons as dots. And you've got 1, 2, 3, 4. Now this is the interesting thing. You've got 6 electrons, you're 2 short, so you need to share 2 electrons. So the electrons you're going to share are going to be like this. So what's happening is you've got 2 pairs of electrons being shared, and you end up with a double bond like this. So each of these represents a pair of electrons, you see. So now if you have a look at this oxygen, you've got 1, 2, 3, 4, 5, 6, 7, 8. That's good. And this one has got 1, 2, 3, 4, 5, 6, 7, 8. So that's good as well. Okay, hope that makes sense. You can also have triple bonds. For example, nitrogen, anything in group 15. There we are, dead easy. Okay, I'll see you in the next video.